Hi, it's Todd here from Todd's Workshop and Todd Cutler, and I've had a workshop accident, and it's an accident that has resulted in me having to make one of these, and it is a 3-bowed Chinese siege crossbow, known as an oxbow. So powerful they needed oxes to draw it back, and this thing was invented round about 500 AD, and they ran through until really gunpowder came in for the Chinese, so probably around about 1300. By 1500, they found one in an arsenal somewhere in a castle, and the guy who found it thought it was really old-fashioned. So it was really old school by 1500. But that is about an 800-year working lifespan, so it must have been one heck of a weapon. So of course you're all asking yourselves, what kind of an accident makes Todd go and make a triple-bowed Chinese siege crossbow? Well, it was this. It's a crossbow trigger, and I accidentally made it the wrong size. But of course, it's not actually the wrong size, it's the wrong size for the project I had in mind. It is actually a good size for one of these. It is a crossbow trigger for a siege weapon. That was my accident. So now that I have the trigger, I better go make a siege weapon. But if I'm going to build a Chinese siege crossbow, I want to do one of their bonkers ones, because they did sort of fairly normal type stuff, effectively the equivalent of the European rampart bow. So a regular kind of handheld bow, but just bigger. And they called them bed bows. They probably went on a big frame. But they did the triple bow, the ox bow. So what we've got going on here, very obviously, are 2 bows facing forward and 1 bow facing backward. That makes it immediately very interesting and very, very odd. Now you can see that they're all interlinked here, and you've got to sort of follow the logic of what's happening with the string. So that's the main string there. If you pull that back, it has to deflect these 2 bow limbs here. Well, these are obviously doing something as well, so it must be pulling this one down and that one up. And so what it's doing is it's bending all of the bows together. So these 2 are bending both in at the same time, and that one's bending in at the same time, but in the opposite direction. So the first thing I needed to do was to make a little model so that I could just kind of make sure that my logic, what I was seeing, made sense. And this is the first one I did here. Now, all the bows in here are of equal strength. I wasn't expecting that they needed to be of equal strength, but I just wanted the layout just to see in my head and my hands how the thing operates. So if I pull the string here, you can see that this bow is flexing the most. This one's flexing a bit, and this one's flexing a tiny little bit. So I'll just show you again. Now, what you can also see, I hope, is that the maximum draw length of this one has now been extended because you're bringing in draw length from the other 2 bows. You are extending the power stroke of this whole set of 3 bows beyond the power stroke of any one individual one. And we're going to come back to that, but power stroke is vastly important when it comes to the speed of shooting arrows and bolts. So what I can see from here is that these bows need to be of different weights. I've assumed very simply that this one needs to be 2 times the weight of this one and 4 times the weight of this one here. So what that means is by harnessing all of these bows together in this layout, you can extend the draw length hugely. And that is a massively important thing. And now, a word from Todd Cutler. There's Fridays, and there's Todd Cutler Black Fridays. And our prices are on fire. We're slashing prices. We're smashing prices. Some of our prices are even cut in half. The Todd Cutler Black Friday sale. Do not miss it. And back to the film. So then I built a slightly more sophisticated model, and it's this one here. So now what I've done is I've made this bow, I've measured them out, roughly twice the weight of this one and roughly 4 times the weight of that one. It's all a bit crude, obviously. But you can also see that the flexion on them is not correct. But you can also see that things are really beginning to get quite interesting indeed now. So I'm getting a very long draw length off this bow. So I'm definitely on the right track. But just watch as I relax the string now, how these limb tips here are closing up and then they open up. It's friction in the system because it's just running on these rings here on the limb tips. There's no pulleys here. But nonetheless, it's just got my knowledge on a little bit further. And even though this is just a rubbishy little model, it still allows me to shoot quite effectively. Now let's look at this picture again. So you can see here on the limb tips and where the cords are passing through and connecting that there is no detail. You cannot see how those cords are running there. So they could be running through a little ring like that and it worked perfectly well, but it's high friction, but lightweight. You could put them through a small pulley there, which would be much lower friction, but heavier weight. Now the thing is, it means that there's advantages to doing it both ways, and we don't know how they did it. But intuitively, my guess is that they're going to go for the lower friction route. And if nothing else, because it's going to make the strings more reliable. Because strings do not like being pulled, cords, ropes, don't like being pulled over very tight radiuses. It weakens them. So that's why, fundamentally, one of the reasons that we use pulleys, which are significantly bigger than the diameter of the cord. So I think they're going to be using pulleys. And I think they'll be doing it out of a lightweight material for the pulley wheel itself, like ivory, nice and strong, brilliant. Obviously I'm not doing that. And a small, fairly lightweight, but strong enough steel shank on it. And it's not going to introduce too much weight on the limb tips. So I'm going to make my one using little pulleys. This weird friction that is happening here and is changing the position and the sequencing of the bows, I think is going to pass, and you're going to end up with a much cleaner draw throughout the whole system, and that has got to be a great advantage in any weapon. Improves the reliability of the cords, probably improves the actual overall efficiency of the machine itself. So that's fantastic. Now the question is, how long a draw length are we going to do? Now the reason that I find this trigger system really interesting is its relative simplicity to manufacture, its ability to manufacture it in bulk, and the fact that it is wildly different to the European system. But this was invented around 500 BC. This lasted 2,500 years. It is that good. So I'll show you the European system first. So this was invented by the Romans around about 3rd century. Have a look at this stone relief picture here. You can just about kind of make out, if you know what you're looking at, the rolling nut system on it. Now that system wasn't superseded really until about 1550, for most people 1600. So when it became a sporting bow, not a military bow, this was abandoned and more complicated locks came in. But until that point, this was the lock that stayed. But it all needs to be made of steel. But not just any kind of steel, it's got to be really hard at this point, because the entire load of the bow is going through this sear face here and into the nut. So the string is held there where the elastic band is, there's the trigger, and you release. All of that load goes through that face on the nut and that part of the trigger. That means it wears. It means it's got to be very precisely manufactured. It's got to be very carefully manufactured by proper high-spec, well-paid artisans. This is not amateurs' work to make these locks. The Chinese system was wildly different. So because it was made of bronze, you couldn't rely on those sear faces to hold the whole weight of the bow. So they didn't design the trigger like that. Now what happens when the trigger is loaded is that the force, the rotational force on this nut, is put onto this section of the casting that goes through there. But you'll just make it out as I rotate it around. And that engages with the sear here. But what that means is that in the loaded position, the weight is transferring, or a great deal of the weight is transferring down into this sear and through into the pivot. It's not onto the sear face itself. It means that you can mass produce them with casting and a little bit of fettling, and that is cheap labour, mass production labour. So here is the main string catch unit, then the trigger itself, and then the sear. So it's a very clever system, long-lived, cheap to manufacture, relatively straightforward. So the Chinese used it on crossbows, but the thing about their crossbows was they used regular hand bows for it. It's got funny string on it, ignore that. But they used regular hand bows like this. When they wanted a crossbow, they were able to effectively, in kit form, build a bow using their regular hand bows as well. So it gave them more flexibility in their weaponry and their arsenal. So their crossbows had the same power stroke as their hand bows, 20 to 22 inches. 50 to 55 centimetres. So what does that mean for our machine here? The drawing, you can see, it's obviously slightly fanciful, but it's clearly wrong, because those limb tips have got very little travel before they touch. And that's going to be no good at all. So this has been drawn incorrectly, that bow must be further back. It's got to be. But it also means we cannot do any kind of scaling off that to work out draw lengths. But what we do know is that their draw lengths on their regular crossbows were the same as their regular hand bows. So if we assume that that's going to be much the same for that, you're going to get 3 hand bows in there. Now I still need to sort of work through the maths of this and the actual operational nature of it. So what that means is we're going to end up with a power stroke distance of 1.5 to 2 meters. I'm not exactly sure yet. Again, coming back into feet, that's going to be what, 6 to 7 feet, something like that, on the power stroke. Now that is going to be extraordinary. And it brings me right back again to the nature of the name, the 3 ox. It seems to be there's an assumption that these things are so powerful that they need oxen to load them. Well, to make bows like that is really difficult. To make seriously heavy bows of those kind of draw weights out of composite materials or wood, really tricky thing to do. So I doubt that it needed a team of 8 oxen to pull it back. But you could see, again from this picture here, that we have got a windlass on it. So it could be that the windlass itself is required because it is so powerful you need the windlass. It could just be that if you have got a spanning length of 1.5 meters, how do you actually span that? Physically, you can't reach the string and pull it back. You have to have a windlass. And it doesn't really matter even if it's a 30-pound bow. You need a windlass to do that. So how powerful were they? Well, I can't answer that. I don't really know. There are numbers out there saying sort of 300 pounds, 400 pounds. Maybe it is. I can't and I won't go to that. So what I'm going to do for my one is I'm going to buy 3 of these bows at differing weights. So maybe 20, 40 and 80 pounds as an example. And I'm going to start working with that. If I get excited and I get success, then, well, you know what? Maybe we'll go up from there. But this is my expectation, is that if we can have a bow that draws 80 pounds, 90, 100 pounds, with a 1.5 meter long power stroke, it is still going to be awesome. So the next time you see me talking about these ox bows, these triple bow Chinese siege weapons, with a bit of luck, I'll have a functional one in my hands. And it all happened because of the lucky workshop accident that was my Chinese crossbow trigger. Well, anyway, I hope you've enjoyed this, and watch on because there will be more to follow this, because I've got the bug about these things and this is just too interesting to leave. But don't forget, we've got a Patreon site, that's really helpful as well. And we've got the second channel, toddcutler.com. It's got like more niche content on it, and our websites. If you're not familiar with our websites, go check them out, because if you love this kind of historical content, you will absolutely love those. Chock full of weaponry, all sorts of interesting things that you will like. Anyway, I hope you enjoyed it, and I'll see you again.